The drug Depo-Provera is often used for patients who exhibit hypersexual behavior caused by traumatic brain injury, TBI. The results of a study conducted on 8 patients who exhibited such behavior are included below. Each patient had their testosterone levels taken before treatment with Depo and after treatment. At the 1% significance level, test the claim that the drug is effective at reducing testosterone levels in TBI patients. Okay, so there's a little typo here. I had to pen in here. I wrote TMI. That would be too much information, as opposed to TBI, traumatic brain injury. Okay, so I've corrected that in the actual hard copy of the notes, but let's look at this problem. When it says, at the 1% significance level, test the claim. So I know it's a hypothesis test. That's easy. It says, test the claim that the drug is effective at reducing testosterone levels. Now, there are 2 things in this problem that tell me this is a matched paired t-test or a dependent t-test. The reason why I know that is because, first of all, I can see the data layout, right? It looks like there are 8 patients, but there are 2 scores for each patient, a pre-treatment and post-treatment score. That means each patient was tested twice, so these 2 rows are not independent of one another. They depend upon the patient that they came from, right? So if one patient had a higher testosterone level to start with, right, that'll have some effect on the level of testosterone after treatment, right? So there's a dependency here in the data. It also tells me in the problem that each patient had their levels taken before and after the treatment. So each patient was tested twice. Okay, so based on the layout of the data here in the table and what it says in the problem, it's the matched paired or dependent t-test. That means I'll use a claim that involves subtracting a before and after mean. So let's go ahead and write the claim here. And in this problem, if I read the phrasing here, it says at the 1% significance level, test the claim that the drug is effective at reducing testosterone levels. That would mean after treatment, the levels should be lower. Now, if you look at the way they did the subtraction here, you can tell, because they have the column of differences, or the row, pardon me, of differences given to us. You can tell they must have subtracted 96 from 849 in order to get 753. If they didn't do that, if they did it the other way around, that would be a negative 743. So if they did 96 minus 849, we would have had negative 753. So it's clear that they did basically like before minus after. So you could write it as the mean for pre-treatment, right, is connected or related to the mean for after treatment. And if we do it that way, and why did I do it in that order again? Because that's how they did the subtraction, pre, minus, after. And if I think about it, what is it saying? It's saying that after the numbers should be lower, and pre, therefore, they should be higher, right? So what they're saying is that before the drug is administered, it should be a higher level of testosterone than after. So this is the proper relationship. Now, if I pick this up and I moved it over, that would form a difference between the means, right? So it would have mu different, right? Mu differences, the mean of the differences. And it would still be greater then, right? If I move this over, that symbol doesn't change, but now there wouldn't be anything over here, so it would be 0. So this is the same as my claim, right? It's just written a different way to reflect that we're doing a problem related to the differences. We're not going to treat the individual rows separately. Okay, so that method of using just the row here, that's called a blocking technique. So since we're using blocking, we're going to convert our claim into just the idea that the mean difference is greater than 0. All right, now that we have that, we're going to get HO and HA. Now, if you look at the symbol that's involved in the claim, it's clear that the claim is HA. And that means that HO would have to express the opposite relationship. So if it's not greater than 0, it must be less than or equal to 0. Okay, so you have your claim, you have your HO and your HA. Our next step is to do the data. Now the data here, if you look at it, there are n differences, right? So the number of differences, as I said, there are n differences, there are 8 differences, right? The number of differences is 8 because there are 8 patients in the study. And then we need a sample mean and a standard deviation. Now, these items, to get the mean is easy. We just add all these up and divide by 8. To get the standard deviation, it's a little bit more work. So I've actually done them for us already, and I'm going to write them down. And again, I believe most teachers usually give these to you, so you don't have to do them yourself. Sometimes in the homework, they might make you do that, but not so much in the actual test itself. Okay, so 224.777, right? All right, so there's the ND, the X bar D, and the standard deviation of the differences. And then lastly, we need to get the alpha for the problem. The alpha here is given as 1%. Okay, so now that we have the data, we've got our step 3 accomplished now, right? The next step is to get the test stat. The test stat, remember, is quite easy here. It's just that formula T, right? And the T formula will be x bar minus the difference from the null hypothesis divided by the standard deviation of the differences divided by the square root of n for the differences. All right, this d sub 0 is 0 because HO doesn't have a number in there, right? Just 0. The standard, the mean for the differences is 749.5. The standard deviation is 224.777 approximately, divided by the square root of 8. All right, let's enter all that in our calculator and see what that ends up giving us here. So we'll have 749.5 divided by, open parenthesis, 224.777 divided by the square root of 8. And upon doing that, we get quite a large number. We get 9.43. So that is a very large number. And from there, let's see what that gives us for our conclusion. It would seem that we're going to reject the null hypothesis, of course, right? 9.43 is off the charts big, but to be sure, we should do our critical value. So we're going to draw the bell curve, just like we always do for the critical value. Then we will determine whether it's a right-tailed test or a left-tailed test. If you look at HA, you can see that that's a symbol pointing to the right. So once again, this is a right-tailed test. Now, if you think about our alpha in the problem, our alpha was given to us as 1%. So this means the number down here, our critical value, is going to be t.01 with 7 degrees of freedom. Let's go to our table and find that number. Okay, so we're going to be in the 0.01 column with 7 degrees of freedom. That's 2.998. Okay, so our number was 2.998. 2.998. That's our critical value. It's clear that our test stat is way over here in the rejection region. So we're going to conclude that we reject the null hypothesis and therefore support the alternative. And with that pair of initial conclusions, we'll look at our claim and say, hey, our claim in this case was HA, so we should use this wording. We're going to say we support the claim. The sample data supports the claim. The sample data supports the claim. And what is that claim? Well, the claim is that essentially taking this drug, Depo-Provera, will lower the testosterone levels. So after injection of this drug, they'll have lower testosterone levels, these patients that have had a traumatic brain injury, which has raised those levels artificially.